Alright, we will still be finding volumes of solids, and we will still be taking two-dimensional shapes and turning them into 3D, but instead of using the disk method today, we're going to be using the shell method. So at the end of this lesson, you'll be able to find the volume of a solid of revolution made by revolving a region around a line using the washer method. If you recall in that last video when I showed you a video of something being revolved around the x-axis, we had something that looked like this, and then we had something that looked like that, and then we were revolving it around the x-axis, and what happened was we ended up getting something that had a hole in it. I don't know if you remember seeing that, but it actually had a hole in it if we did it 3D. So what's going to happen if I were to draw that circle? There actually would have been a hole in that circle. And what we would like to do, just like the disk method, we're going to be finding the area of a whole bunch of circles and then adding them together. The biggest thing though on this one, this time, all of our figures are going to have holes in the middle, or they might not actually have a hole all the way through, but they'll at least have a space. So if it looks like something like that, we're going to use the washer method instead. So thinking back to geometry, when you found the area of a circle, or the area of the shaded region, if you recall, you always took the area of the outside circle and you subtracted it from the area of the inside. And when you did that, that would create the shaded area in between. So that's exactly what we are going to do. If you'll notice this one, it looks very similar to the disk method, but basically what's going to be happening is we're going to take, it's still pi, and then we're going to take the radius, so it'll be pi r squared minus pi r squared. So you'll notice it's going to be the radius of the outside circle minus the radius of the inside circle. And since we're actually doing the areas for both of them, both of the radius, they're both r squared in each case. So the big R is always going to be the outer radius. And just one hint that I'm going to give you as you're doing this, because sometimes it's hard to figure out which one's on the outside of the shape. It's always the one furthest from the axis of revolution. And then for the little r, it's going to be the inner, so it's forming the inside of your shape, and it's always going to be the one closest to your axis of revolution. So hopefully that will help you out as we're getting into it. So we're just going to go ahead and jump right into these problems. All right, looking at example 1, that should say example 1 there. Okay, we're going to find the volume of the solid formed by revolving the region bounded by the graphs of y equals 4 minus x squared over 4 and y equals 2 about the x-axis. So what we are going to do on this one is we are going to go ahead and draw a picture, and you always have to start by drawing a picture. And 4 minus x squared over 4 is going to look like a parabola. It's a little bit wider parabola, so we're going to have something that looks like that. And then if you graph y equals 2, we're going to have something that looks like that. And since those are the two boundaries, my shaded region is going to be right here. And we're revolving it about the x-axis. Still, we're always going to be about a horizontal axis of revolution. So if I revolve it about the x-axis, what's going to happen, it's going to actually just kind of mirror over on the other side. So it's going to look something like that. And basically what's going to happen, if you can kind of think about this, that's all going to be filled in. So if you can kind of think something that looks like that, it's got a hole that goes all the way through the middle. If you're into crafts, you probably recognize that as being a bead that you might use for a bracelet or something like that. So we will call that a bead. And no, we will not be eating beads tomorrow in class. Alrighty, so if I would like to find the volume of this, we're going to do volume equals pi. We need to figure out that it goes from where to where. And since I'm going to deem this to be a calculator section, we can actually go ahead, if you have those two in your calculator, we can go ahead and calculate and find the point of intersection. And if we do that, we're going to get negative 2.82843, and this is actually positive 2.82843. Notice again, I went out 5 places because I need to be accurate to 3 places when I'm done with the problem. Okay, now to figure out, remember our formula was the integral of capital R squared minus little r squared. So when we do this, the outer shape, so which curve is forming the outside of the bead, it's the parabola part, so it's going to be 4 minus x squared over 4 squared. And then minus, which one is forming the inside of the bead? It's just the straight line, y equals 2. So it'll be minus 2 squared And then, of course, the whole thing is dx, and we have it set up just to make sure on this one. Again, if you're not sure which one goes first and which one goes second, the parabola is the one furthest away from the x-axis, and the line y equals 2 is the one that's closest to the x-axis. So that's how you can tell which one to put first and which one to put second. And then from here, we're going to let our calculator do all the work for us. So if we press Math 9 on this one, we should end up getting 132.694. And again, I would encourage you, even though you're just getting to write down my answers, I'd encourage you to actually type it in yourself. Look for the points of intersection yourself so you know exactly how to do it. All right, question 2 says to find the volume of the solid formed by revolving the region in the first quadrant. So first quadrant bounded by the graphs of y equals 9 minus 2x squared, x equals 0, and y equals 1 about the x-axis. So again, the first thing that I want to do is draw a picture. And if I draw the picture, 9 minus 2x squared is going to look like a parabola, something like that. And then y equals 1 is going to look something like that. And then x equals 0, so x equals 0 is going to be right here. And it's just the part in the first quadrant, so if you look at which part is which should I shade, whoop, it's just going to be this, this part right here. So that's the part that's where we're going to be revolving. And we're going to revolve it about the x-axis. So if I revolve it about the x-axis, it's just kind of going to make a mirror over the x-axis, so it's going to look something like that. So you notice this shape is going to have a flat bottom, and it's going to have a hole in the middle, and it's kind of rounded on the top of it. And if you can kind of picture it sideways, in my opinion, it kind of looks like a fudge striped cookie. So maybe you think it looks like that too. Alrighty, so from here, we're going to go ahead and find the volume. We're going to do volume equals pi. We need to figure out it's going to go from an x value to an x value, and again I can obviously see that it's going to start at 0, but it's going to end where they intersect. And I am going to just, even though we get to use our calculator for this one, I'm going to set the two equal to each other to see where they intersect, so that it would be at the line. We have 9 minus 2x squared is equal to 1. And so then if I subtracted 9 from both sides, I'll get negative 2x squared equals negative 8. And then I'd get x squared equals 4, so x would technically equal plus or minus 2, but we're only in the first quadrant, so I just need 2. So it's going to go from 0 to 2. And again, if I do get to use my calculator, I could do point of intersection for that one, and we would still also get 2. All right, so now since there's a hole in my graph, I actually need to do the outer radius squared minus the inner radius squared. The outer radius squared is actually going to be the parabola. That's the one that's furthest away from the axis of revolution. So we're going to have 9 minus 2x squared, and don't forget we have to square it, and then minus the inner radius squared. The figure that's closest to the x-axis would be y equals 1. That's forming the inside of the shape. That's what's making it, the hole in the middle is going to be y equals 1, and we're also going to square that. Okay, and then from here, I am going to go ahead on this one again and use my calculator, and if I do, I will get 281.487, and that would be my volume. Alrighty, let's take a look at the next one. Example 3, not 1. Okay, so this time we're going to revolve the region bounded by the graphs of y equals the square root of x and y equals 2 and x equals 0 about the x-axis. So again, let's get a picture drawn so we know what's going on here. We have y equals the square root of x. We have y equals 2. We're actually going to intersect y equals 2. Whoops. Sorry about that. And x equals 0. So if we look at that, it's not going to be this region down here. It's actually going to be this region right here. And we're revolving about the x-axis. So basically what's going to happen is this shape is going to repeat over on the other side. And so if I revolve it, I'm just going to try to make it look like a three-dimensional figure here. Okay, so if you look at it, we've got a flat bottom, we've got a flat top, but then what's going to happen inside, it's kind of bowing. And if you are familiar, if you've ever seen where people collect shot glasses, or it might be a vase, where the outside is nice and it's got a circular outside, and then we've got this bowing in on the inside. So we are going to some sort of glass, we'll put, or vase. All right, so we've got pi, and then it's going to go from 0 to where they intersect, and to figure out where they intersect, we're going to set the square root of x equal to 2, and then if I square both sides, I'll get x equals 4. So it starts at x equals 0, it ends at x equals 4, and then I need to look at what curve is forming the outside of my glass. It's the curve y equals 2. And again, that one is furthest away from my axis of revolution between the two that I have to pick from. And then minus the one that's forming the inside of my glass is going to be the square root x. And that's the one that's closest to the axis of revolution. And I also have to square that. And we are going to attempt to do this one non-calculator. So I'm just going to get rid of some parentheses here. I'm going to have 4 minus the square root of x squared is just going to be x. And then from here, since there's a minus sign, we can take the integral of each part separately, and that pi is just kind of hanging out. I'm going to kind of ignore it. I'll just keep carrying it down but ignoring it. So when I take the integral, I will get 4x minus 1/2 x squared. I get to evaluate it at 0 and 4. So again, kind of ignoring my pi there. If I plug 4 in, I'll get 16 minus 8. And then minus, if I plug 0 in, I'll get 0. So then 16 minus 8 gives me 8, and then I'll also have my pi. So the volume of that specific figure would be 8 pi. All right, let's try one more. We want to find the volume of the solid formed by revolving the region bounded by the graphs of y equals 3x squared, y equals 4, about the line y equals 7. Okay, so when we do this one, we're going to have y equals 3x squared, and that's going to be a pretty skinny parabola. So something that looks like that. And then we have y equals 4. It's going to look something like that. And that's it. So this is going to be my shape right here. And this time, notice we're going to revolve it about the line y equals 7. So we're going to go, this is going to be my axis of revolution. So that's what I'm going to revolve it about. And so if I revolve it about that line, it's going to be revolving this way. So it's actually going to mirror up here a little bit. So it's going to look something like that. So it's going to leave this big hole in the middle. And if you can think of what that might look like, in my opinion, I think it kind of looks like a lifesaver. And if you're having trouble visualizing it, you can totally get the answer without. All right, so we're going to have volume equals pi, and then we need to figure out, here's my left side and the right side, so it's going to go from what x value to what x value. I'm going to use point of intersection on that one, and if I do that, I should get negative 1.15470, and then my other point of intersection is 1.15470. Notice again, I went out 5 places so that I'm 3 places accurate when I'm done. And then if I want to get the outside, which one is forming the outside of my figure? So here's my axis of revolution. Which curve is furthest from the axis of revolution? It's actually the parabola. So we're going to take 3x squared. And I actually, on this one, just like we did on the disk method, since it's at the line y equals 7, we need to actually move it to the x-axis, so we're going to subtract 7 from both of our figures. So we're going to have 3x squared minus 7 squared, because it's radius squared, and then minus the curve that's forming the inside of the lifesaver, or the one that's closest to the axis, is y equals 4. But again, we're going to subtract 7. So when we did the disk method, we only subtracted it from one shape. Now we actually have to subtract it from 2 shapes, and of course I do need to put squared there. And then the whole thing is with respect to x, of course. All right, from here, we are going to go ahead and calculate this calculator, and when you do that, you should get 177.994. Just one quick comment on this one. If I did ask you to work this non-calculator, please just remember that 3x squared minus 7 squared really means 3x squared minus 7 times 3x squared minus 7. So I'd actually have to FOIL that out before I actually took the integral. So hopefully now you can calculate the volume of a figure using the washer method.